with any luck, the first couple of these, especially the first one, should have been really, really fast. Okay? Remember how we always say that we're looking for, as you try to do your scale, you're always trying to look at your, what are called constraints, to automatically search for largest or smallest intercepts. In this case, the largest intercept is going to be at 6, and it's a first quadrant problem. Are we okay with that? Reasons first quadrant tells me this here. I know I don't have to plot anything negative. Remember yesterday we had the example real quick where we had that negative x-intercept, and we still drew it coming up and through. Even though it's going to be first quadrant, we drew the second quadrant just so that way we knew some visualization of where it was heading towards. Same deal here, but we have first quadrant only. Excuse me. I know I'm at 6, 0, 6, and I'm at 3. Connect the two. Did it go through the origin? No. No. So what's 2 times 0? What's 0 plus 0? Is 0 smaller than 6? So we know we get this bounded region within here. The only thing I had to figure out then is what's that third point of inflection. Remember, point of inflection is where the graph changes color, changes direction. 0, 0. So these 3 ordered pairs are the points at which you would substitute into your objective function. The objective function is this, remember this guy that's denoted by the letter C. And then we just substitute in 3 times 0 plus, or I'm sorry, minus 6. 3 times 0 minus 0. And then 3 times 3 minus 0. All I did there is I took those 3 separate ordered pairs, threw it in the objective, and I hit enter. I get -6, 0, and 9. Which one of those is the largest? 9. 9. Now here's the thing. 9 is the maximum value. The maximum value occurs at the ordered pair 3, 0. And these questions here, they're asking us what is the maximum value. Thanks, sir. They're asking us what the maximum value is. So all you have to say is 9. And when we get to the word problem stuff, it'll be how many things did you have to make? Like how many coffee pots and spoons did you sell? Well, I sold 3 coffee pots and no spoons, and I made my most profit at $9. That's kind of the idea of where things get to. The ordered pairs will mean something next week. Not today. Today it's just X and Y values. Okay. The minimum value that occurred at -6, so your minimum value is -6. That means if I sold no coffee pots and I only sold 6 spoons, I lost money. Doesn't seem like a good thing to be selling is spoons. Okay. We'll talk into it. We didn't have to do it last night, but we're definitely going to do 9 or was it 8? It was one of those we do. Complicated. They're not when I did. All right. In this one here, again, what I always want to do is kind of go through and try to figure out intercepts. This one doesn't tell me that I'm only in first quadrant at all, so I'm going to go ahead and just draw my plus sign. For those of you guys that don't like to draw large graphs, please start drawing larger graphs. It will make your lives better and easier as you go through. Okay? All right. Now, as you go through this, just like we did in the past, we would look for our largest intercepts to scale it off of. In this case, I've got one at 3. The next one's got both at 3. The last one's got one at 3, and then a -4.5. Everybody see that? Again, all I'm doing is just quickly reading through where my intercepts are at. 3, 3, 3, 3, -4.5. So I'm going to put, I maybe count, it says it's only one of them that's out that way. All I do is that one, really. And then the rest of them are basically 3s. So if that one's at -4.5, the other one's at 3, there's my line, and I have to label my ordered pairs here. -4.5, 0, 0, 3. Everybody okay with that? Okay. Excuse me. Now, next one we know, I'm going to go back to the top. The next one was at vertical line at 3. Okay, so vertical, grab your calculator, you need to do this one. You got your vertical line at 3, so I'm going to plot that one to figure out where it runs into the intercept, or that graph. Okay? When I throw that one through at 3, that gives me an x-coordinate at 3. Okay? Gives me an x-coordinate at 3, which means when it hit that graph, you already know the x value. So you throw that in. This will be at 3, comma something. Oh, before I get that far, remember I have to shade that one going in this way. I got to make that one coming inward, all right, because it's less than 3. Oh, I forgot to shade that one. I'm sorry. What's 2 times 0?
0.
What's 3 times 0?
0.
What's 0 minus 0?
0.
Is that bigger than negative 9?
Yes.
Okay. So I forgot to do this. My bad. Okay. So right now we've got those two values set, moving inward. Are you guys okay that we know that since this is vertical, it hits this one, that means the x-coordinate has to be 3 for that? So I take the value of 3 and I substitute in here, and I get 2 times 3 minus 3 times y is negative 9. Remember, when you're solving the systems, treat them as an equal sign back. All right? What's 2 times 3? 6. If I move the 6 to the other side becomes negative 15. Good. Negative 15 divided by negative 3 is 5. Write it down then. Use a calculator. There's no excuse. It's arithmetic. You shouldn't overthink it. All right? Seriously. Don't. Just press a button. Okay? Yeah. Yep. Because you agree that that's where those two, no matter what, since it's vertical, the x value remains constant and hits that horizontal or that diagonal line at the value of x equaling 3. What's the y value? Throw it into the equation. I put it into this one because this is that equation I just graphed. That's this line.
That's that one.
Yep. Okay. This, as we get into some of the ones that have more lines to it, it'll be a little bit cleaner if you have more than one color. It helps to see which one you're running against. And then lastly, we have intercepts at 3 and 3. Not too terrible to work with. 3 and 3. And with that one, with that line, how it hits the first one with the positive slope and the vertical, it runs into already the same exact intercepts. So you don't have to map those intercept parts. But we do have to ask the question, what's 0 plus 0? 0. Is that bigger than 3? No, so it's false below, which means true above. So here's your shaded region that you would get, and that gives you 3 points of inflection. Remember, points of inflection is where the graph changes. Direction. Hi. Good morning. Anyway, so you test it at 3, 0, 3, 5, and 0, 3. Remember, each one of those is that value. It does not matter which order you label those in or write those out. You're still going to see which one becomes maximum, which one becomes minimum, by throwing it into your objective function. So you get 2 times 3 plus 4 times 0, otherwise known as 6. 2 times 3 plus 4 times 5, otherwise known as 26. 2 times 0 plus 4 times 3, which is 12. Which of those is the largest?
26.
26. So your maximum occurs at 26. The minimum occurs at 6. The ordered pairs, again, doesn't really matter what they are right now. But as we get along into this, you'll start to see what they represent. Okay? Then? then we did 7, right?
Yeah.
Okay. And we started 7 in class, didn't we? I thought we did. I swear I did 7 in class. Before we get into number 6, if you start to read the bakery problem, you'll start to understand what does it mean when I'm talking about the ideas of these x and y values, what do they actually represent? So if you read the bakery problem, it says, oh, I didn't, that's right, I got rid of it so you didn't have to see it.
It says a bakery.
Yeah. Well, I'm not going to worry about it then. I'll worry about it on Monday. Do that. So let's get 6, okay? Number 6, we have an objective function, and we have 3 inequalities. The 3 inequalities are straight inequalities. There is not one that says x is greater than or y is greater than. So this one is, all 3 of them have lines that we have to plot, which means we're going to have to find some intersection points. Okay? Now, when we find intersection points, that means that we're going to find and solve systems of equations. Last time we did some system of equation stuff with graphs, sometimes you guys got some really, really crummy values. I remember you were trying to figure some of those out, and I said, that's going to happen because they're not designed for that purpose. These, they should work clean-ish. A lot cleaner than what they were in the past, okay? So, as we get into here, I have to start thinking of scale. As we do that, y-intercept 4, x-intercept 8/3, y-intercept 4, x-intercept 2, y-intercept 1/2, x-intercept 2. Which means the largest intercept that we could get here is going to be a 4. Are we okay with that? Just quick covers and solves. You're looking at that in your head, trying to figure out how do you want to scale it through. So I'm going to do my full graph. I'm going to go 1, 2, 3, 4. Straight through. Okay? And I know if you have different colors, it's a great time so that way you know what line runs into what, so you can see your intercepts a little bit better. So I have x, I'm looking at the first equation, 3x plus 2y is less than or equal to 8. The y-intercept is easy, that's 4. The x-intercept is at 8/3. 8/3 is really, really close to 9/3. 9/3 is how much? 3. So 8/3 would be a smidge less than 3. Okay. A smidge less than 3 here-ish. And I label it as 8/3, 0. Okay. For those of you guys who are getting decimals and stuff, stop using decimals, please. Please. No more decimals. There's a button on your fraction, or there's a fraction button. Use it. Okay. There's a button on your fraction. There's a fraction on your button. That too. Did that go through the origin?
No.
No. What's 3 times 0?
0.
What's 2 times 0?
0.
What's 0 plus 0?
0.
Is that smaller than 8?
Yes.
So it's true, so we cover the truth.
Because we're shady.
We're shady people, yes. Okay? All right. I'm going to change colors to do the next graph. I have a y-intercept at 4, and I have an x-intercept at -2. Are you okay with that? 4, well that's nice. I don't have to worry about doing another set of ordered pairs there because it's the same one. And then the other one is at -2 for this guy. All right, connect them. Let's ask some questions. Did that go through the origin?
No.
No. So what's 2 times 0?
0.
What's 0 minus 0?
0.
0. Is 0 bigger than -4?
Yes.
Yes. Again, cover the truth. Okay. Right now we're bounded in that region there. We have a third line to graph. The third line has the y-intercept at 1/2, the x-intercept at -2. Oh, that's convenient. -2 again. And then I got to plot one at 1/2. So that is at 0, 1/2. Draw my line. Okay. Everybody see how it hit this one here?
Yeah.
That means we have to find the intersection of those two. That's what we have to find. We don't have to find all the other intersections because this one was nice. Those two lines intersected at the y-intercept, which is great. This one hit here. Oh, we didn't go through the origin yet. What's 0 minus 0?
0.
Is that smaller than -2?
No.
No. So it is false, which means it's true. So right now we have 2 of our points of inflection. We have to get this third one. To do that, we solve this system of equations. So, easiest way to do that one is we have what? 3x plus 2y is 8. What I'm going to do with this one is I'm going to use substitution. I am one step away from having x by itself. Everybody see that?
Yeah.
So I can say that x is 4y minus 2. Remember, when you're solving the systems here, you treat them just like any other regular equation. Substitute in 3 times 4y minus 2. Yeah, I moved it over. And then is 8. So I have 12y minus 6 plus 2y is 8. Combine your like terms, you get 14. Move this over, you get 14. So 14 divided by 14 is?
1.
So what's your y value?
1.
A lot of times this stuff works out pretty quick, or rather quickly. I don't know the correct terminology, I guess. No, don't, because it's not always going to be clean. Stop using graph paper. Seriously, stop using graph paper. Not good for you. So my y value is 1, which means I just throw this back into here. What's 4 times 1? 1. What's 4 minus 2? 2. So your x value is? 2. So this ordered pair is at 2, 1. That gives us our 3 points of inflection to test. 2, 1, 0, 4, and -2, 0. Okay. What's 2 plus 5? 7. Very good. You sound so excited you're able to figure out 5 by 7.
That's like a phone number.
That's 867. I was actually going 8675309, but that's okay. Oh, Jenny. What's 5 times 4? 20. What's 20 plus 0? I knew I was going to get you guys on that one. How many times do we say 0 plus 0? 0. Great, very good. So you get a maximum value at the 20 and a minimum value at -2. You were talking about 8? What's the 8? Let's do it. If you look at number 8, I wasn't. Gentlemen, come on. So here you got your 4 constraints. X is greater than 0, so it's going to the right. Y is greater than 1, so it's moving up. So it's kind of first quadrant-ish to start with. Then you've got 2 other sets of constraints. Y-intercept at 6. X-intercept at 1.5. Y-intercept at 2.5. X-intercept at 5. So if I scale this one maybe to be 6s, just to be on the safe side, even though I know it's only going to be over in here anyway, but our y-intercept at 6, and then my x-intercept, I'm not going to worry about moving back in this direction at all because none of them are going to be negative. So I can kind of erase that if I want. Oops. I have to take it all with me. That. X is greater than 0, so we're moving to the right. Y is greater than 1, so it's moving up a horizontal line through 1. Okay. X-intercept, y-intercept of the third inequality has a y-intercept at 6. An x-intercept at 6/4, otherwise known as 1.5. Did it go through the origin? No. What's 4 times 0? What's 0 plus 0? Is 0 bigger than 6? No, so it's moving out. Okay? So it's out this way. When it hit here, I know the y, right? If I know the y value, that means 4 times x plus 1 is 6. What's x? 5/4, right? So your ordered pair here is 5/4 and 1. You okay with that?
Yes.
Direct substitution. You know the y value this time. Sorry. You know the y value this time as opposed to the x value last time. Huh? I know, I hate saying that. And then lastly, I have an x-intercept at 5 and a y-intercept at 2.5. 1, 2, 3, 4, 5. 1, 2.5. Hit here, and it hit here. One of those ordered pairs is going to be, oh wait, what's 0 plus 2 times 0? 0. Is 0 bigger than 5? No, so it's going outward again. So here we get this boundary that does this. There's no maximum. Very good. Everybody see how there's no maximum? Because it's continuously opening upward. There's no cap to it. So right away we know that there's no maximum value. There could be a minimum, or should be a minimum though. What we have to do though is figure out our points that it changes. We know that this graph goes this way, so it hits here. That was an easy one. That was at 0 and 6. This one we have to find. That's the intersection between these two here. When I look at those two, I can do the direct substitution again if I want. If I do direct substitution, I can say that x is 5 minus 2y, or I can say, or I can do any kind of linear combination I want. I kind of like doing the substitution when I get to these things, especially if there's a single value. So if I say x is 5 minus 2y, and I get that. So that gives us what? 20 minus 8y plus y is 6. If I take the negative 8 and the positive 1, what do you get? Negative 7, right? If I move the negative 7 to the right and bring the 6 back the other way, what do you get? 14 and 7? What's y? 2. Y value becomes 2. What's 2 times 2?
2/4.
Which is it? Good. And what's 5 minus 4? 1. So your x value is at 1. So this ordered pair is at 1 and 2. So all we have to test then would be 0, 6, 1, 2, 5/4, and 1. We would test those in our objective, 2x plus 3y. Figure out which one's the smallest, which one's the largest. Well, we won't have a large, but which one would be the smallest. Okay? What's 2 times 0? 0. 0. What's 3 times 6?
18.
18. So that's at 18. What's 2 times 1? 2. What's 3 times 2?
6.
What's 2 plus 6? 8. Okay. What's 5/4 times 2? Otherwise known as 5 halves. 5 halves plus 3. 11 halves. There's 8. 11 halves would be what? 5 1/2? Which one of those is the smallest?
5 1/2.
And everybody okay with there being no maximum to this?
Yeah.
Does that make sense? This could do the same thing where there could be no minimum, where this graph is just kind of flipped around, where it's just there's no bottom. The bottom fell out. You're in the. I didn't think it was that funny, but I'll take it. You're a little red now. Let's all stare at her, see how much redder she can get. Oh, let's do it to you too. That's right, I forgot. Let's see if we can get redder. Oh, it's working! Go stand between them with your red shirt. Go ahead, go get between them with your red shoes. Here, put your face next to my shoes. See who matches. Why am I like what? No? Really? Come here. Come here. That sounds like you're good. More pinkish, yeah. Oh, my what pink? That's the point. Thanks, I appreciate it. Don't you feel bad for my wife? Not bad?
You're insane.
Yes. Tonight, I'm going to have you guys do, I have 6 of these I want you guys to try. I will give you a giant hint on how to start number 15. I will have the PDF, everything set up for you guys here in a minute. But I want you guys to do these 6 in section 3, or I think it's page 160. But when I'm looking at these things here, what's that? I think it's 164. It's on the PDF as you get in there. Yes, sir. I think mine's a 3. So, because I bought a 4 for my wife, and then I. No. Anyway, so let me give you guys a big giant hint here on number 15. Number 15. Does everybody see? Everybody see how 15 you're bounded between 0 and 60 for x? Those are vertical lines. You're bounded between 0 and 45 for y's. Yeah. Exactly. So here's the idea. Everybody agrees that it's going to be first quadrant, I'm assuming. Now, the reason why I say that this has to be first quadrant is because those first 2 boundaries are in the first quadrant. Also, if I look at my x and y-intercept of the last constraint, I have a y-intercept at what, 70? And I have an x-intercept then at 84. Does that make sense? So if I say this is 84, comma 0. And then the y value would be at 0, 70. Are we okay with that? I I have to connect those two. So I connect them. Did it go through the origin? No. So what's 5 times 0? What's 6 times 0? Is that smaller than 420? Yes. Shade towards. Okay? Now, next values. X-intercept at 0, vertical line at 0, vertical line at 60. So can I say that 60 is about here? Okay? So that's 60. What's the x-coordinate here? 60. So didn't that run into this equation here? What's 5 times 60? 300. What's 420 subtract 300? What's 120 divided by 6? And this is moving this way. Okay? So far so good? Okay. We know it's also going this way. All right, y value. Y value between 0, so it's moving up, and 45. Now, I already have this value here at 20, so is 45 higher than it or lower than it?
Higher.
So can I say it's about here?
Yes.
Okay. What's this ordered pair? 60, 45. And you're right. As of right now, it is going to be irrelevant because we know that it's bounding this way. So this one is at 0.45. Okay. Now there will be a time that we might have to get into this region, but see how you went vertical, horizontal. You know verticals are your x, horizontal are the y. Okay. Now again, what's this y value have to be? 45. And it ran into that diagonal. Okay? So if I double 45, what do you get?
90.
Double it again.
180.
Add another 90. 270. I don't know what 420 subtract 270 is, but I could probably press some buttons and then divide that by 5. That gets me here. So your bounded region are now in this. So even though it looks really, really, really weird, those numbers are so fast. It's okay to make these graphs bigger. Draw them larger. Waste a little bit of space. It's not going to kill you. Okay. Exactly. You'll be able to read it a lot cleaner. Yep. And that's. This is very true. Okay. It's all good. Because eventually we'll start to read these problems. We'll have a problem that sounds like this. A juice company makes 2 kinds of juice. Orangeade and Berry Fruity. 1 gallon of Orangeade is made by mixing 2.5 quarts of orange juice and 1.5 quarts of raspberry juice, while 1 gallon of Berry Fruity is made by mixing 3 quarts of raspberry juice and 1 quart of orange juice. A profit of 50 cents is made on every gallon of Orangeade. A profit of 40 cents is made on every gallon of Berry Fruity. If the company has 150 gallons of raspberry juice and 125 gallons of orange juice on hand, how many gallons of each type of juice should be made to maximize profit? A lot. What was their objective? Maximize profit. In that statement, I talked about how much profit was being made per piece. There's your objective function. So profit per 1 unit, so much profit for another. How much, then the other constraints were then gallons. How many gallons of stuff did you have on hand of each unit? And then think about it, can you have negative gallons of merchandise? No. It's a first quadrant problem. Okay? And you're bounded within the regions of how much you're constrained by how much material you have to make. Okay? It becomes really, really evident why you have objective functions and how these things play with it as you start to read them. And that's why we've been doing what we're doing to build to the reading part. That we'll read on Monday. Yep. you find you're graphing maximum in the 6. It might take you 15 minutes or so in the neighborhood. If it takes you, if you're staring at this for more than a half hour just quit. It should be about 15, 20 minutes tops. And this is, and I just did this one. So, I mean, this one you look at it, where's your exclamation? You know, where's your exclamation? You can get, I think the one that's, wherever the reason, where change direction. Here I have 1, 2, 3, 4, 5 that are much more region that I would substitute in. That's why we're doing so much work, because this becomes quicker. I hope.